Hi everybody, today we are going to be covering section 5.1, solving simple linear equations. Okay, now as I said in the lecture, our goal is to isolate the variable in these equations on one side of the equal sign. Okay, and I'm just going to go through some examples. I think that's the easiest way to do this, so let's go ahead and do that. Let's see, make sure I've got the right tool here. Okay, so our first example, let's say we have an equation that looks like this. X plus 11 equals 15. Now I know that you can do these by looking at them, but that's not what we're practicing. Okay? What I want you to do is I want you to think of this as the balanced scale that we talked about today in class. And I want you to think about what you need to do to get the x alone. Right now, we're adding 11 to x. So in order to get x alone, what we're going to do is we're going to subtract 11 from both sides. Okay? Subtracting 11 from both sides of this equation. Now, these 11s, so x plus 11 minus 11, well, these cancel out. And I'm left with, on the right side, just x. Drop your equal sign straight down. So on the left side. On the right side of the equation, we have 15 minus 11. And that tells us that x equals 4. Okay, and then to check our answer, we go ahead and plug in x equals 4. So instead of x, we're going to substitute 4. Now it's 4 plus 11, 15. Well, sure it is. Okay, I'm not going to do any more of those checking the solutions until we get into more difficult problems. So I'll just delete that to get some space. Okay, let's do another example here. So this is how you show your work, by the way, in my class at least. I want you to show me what you did to both sides of the equation to get the variable by itself. Now this one is about as easy as they come because this was a single step problem. As we move on, we're going to get into more and more complicated problems. So let's do another simple one. X minus 12 equals 3. Okay, so what we're going to do here, and also when we move on, for this chapter, or for this section, we're only going to be using x as our variable. But later on, you'll see things with a's, b's, c's. You'll see all sorts of levels of variables. Okay, now let's see what's happening to the x. I want to get this x alone. Well, I'm subtracting 12 from it. So what I need to do to get the x alone is I'm going to add 12 to both sides of the equation. Remember, whatever you do to one side of the equation, you have to do to the other side in order to keep the scale balanced, in order to keep the equation true. Okay, so negative 12 plus 12, those cancel out. I'm left with x is equal to 3 plus 12 is 15. Okay, let's do some multiplication division here. We have an equation that looks like this. 6x is equal to negative 15. Alright, well, what's happening to x? I need to get the x alone. Right now, this x is not isolated. It has a coefficient. I don't want any coefficients. I don't want any negative signs with the x. I want the x completely alone. What I have to do here is realize that this is 6 times x. So in order to cancel this out, I'm going to divide by 6. Divide this side by 6 as well. So here, 6x divided by 6, you can see that the 6 is canceled. And I'm left with x is equal to, what's negative 15 divided by 6? Well, it's not a whole number. So we're going to make this as a fraction. I'm just going to simplify this fraction. The greatest common factor is 3. So I divide the top and bottom by 3. That's going to give me negative 5 over 2. Okay. So, let's see here. Am I glossing over something? Yeah, when you're dividing both sides by a number, if the number you're dividing by doesn't go into this number, just make a fraction out of it and try and simplify. Sometimes the fraction won't even simplify. Let's say that I have, I'll do another one real quick, 3x is equal to 7. We'll have to divide both sides of this equation by 3. And This doesn't simplify. So I'm just going to leave my answer as x is equal to 7 over 3. I don't even want you to make a mixed number out of that. I just want you to write it as it is, as an improper fraction, and leave it be. Okay, we'll do one more than both. Actually, we'll do two more than both fractions. So let's do x over 3 equals 9. Now, if you see this and you're freaking out, I need you to calm down, take a deep breath, and realize that seeing x over 3 just means that x is being divided by 3. Okay? X over 3 means x divided by 3. So how do we cancel out division? We're going to multiply both sides of this equation by 3. So let's say 3 over 1 multiplied by 3 on this side of the equation. And look what that does for us. When I multiply 3 times x over 3, I can cross cancel, and I'm left with just x. And x is equal to 27. Let's do one more fraction. Let's say that x over 4 equals negative 5. Okay, here x is being divided by 4. So if I want to cancel that out and I want to get the x by itself, I need to undo that operation. I need to do the inverse of dividing by 4. And that's going to be multiply by 4. So I multiply by 4. Multiply by 4. The only reason I'm writing 4 as a fraction here is so you can see that the cross canceling happens. But multiplying by 4 like this and like this are the exact same thing. So x is equal to negative 5 times 4 is negative 20. Okay, now these were all single step, pretty easy problems. Let's move on to the next type of problem where we have to do 2 steps. Okay. Let's do some examples. So here we have 2x minus 11 equals 5. Now here I've got two things going on with my x. Let's see. First of all, x is being multiplied by 2. You know, I'm going to write that down. The first thing that's happening to x by order of operations is x is being multiplied by 2. The second thing that's happening to x is after it gets multiplied by 2, we're subtracting 11. Okay? Now we want to undo this. We want to get the x back to being by itself. So what we're going to do is we're going to cancel these things out in reverse order, which means the first step I'm going to do to both sides of the equation is, how do I cancel out subtracting 11? By adding 11. And how do I cancel out multiplying by 2? By dividing by 2. So these are my steps for solving this equation. It really doesn't have to get this complicated. You don't need to draw this little map of what steps you're going to take. I like to think the first thing I'm going to do is I'm going to get the x term, in this case 2x, by itself. So I'm going to get rid of the 11. So I'm going to add 11 to both sides of this equation. Negative 11 plus 11, these cancel out. I'm left with 2x. Equals 9. 9 plus 11 is 20. And now the next thing I'm going to do is I'm going to divide by 2. This is x being multiplied by 2. I'm dividing by 2 to cancel that out. The 2's cancel. Gives me x is equal to 20 divided by 2 is 10. And I'll tell you what, let's go ahead and check our solution. Now, to check our solution, we go back to the original problem. But instead of x, I'm going to substitute 10 and see if that makes this equation true. 2 times 10 is 20, minus 11, sure enough, is 9. It checks out. So 10 is our solution. Plug it in, makes the whole thing true. Let's do a couple. 8x plus 5 is equal to 17. Okay, now like I said, the first thing, our goal is the same, it's to isolate the variable. So the first thing we're going to get alone is this. We're going to get this x term. And the way we're going to going to subtract 5 from both sides of the equation. Okay, positive 5, negative 5, these cancel out, leaving me with 8x. Drop my equal sign down. 17 minus 5 is 12. So now, once we finish this step, by the way, we're done looking here. Now we're looking at this equation. Okay, we're looking at this equation. So let's see here, 8x, that means 8 times x is equal to 12. So I need to divide by 8. This is the x is being multiplied by 8. To get rid of the 8, I need to divide by 8. Okay, because they're inverse operations. The x's cancel. Sorry, the 8's cancel. I'm left with x is equal to 3 halves, because 12 over 8 isn't a whole number, but it simplifies to 3 over 2. If you divide the top and the bottom by 4. Okay, now I'm just going to do something. Every step I'm taking is canceling something out. The first step is subtracting 5, cancel out this 5. The next step, cancel out the 8. So we're taking these, subtract 5 here, divided by 8 here. We're taking these successive steps, and each step gets us closer to having the x by itself on one set of these. That's usually true for just about every take a series of steps, and your overall goal for linear equations is to get the x alone and then the number on the other side. That's our goal. Okay, let me just show you something. Now, the main thing is, whatever you do to one side of the equation, you have to do to the other. Now, I'm going to do that same problem I just did. Let's say that I don't do it the smart way, okay, which is subtracting 5 first. Let's say I want to divide by 8 first. I'm going to show you how messy it can get. Okay, so let's say I'm thinking to myself, well, x is being multiplied by 8. I'm going to divide both sides by 8 and see what I get. Okay, so if I'm dividing by 8, and I'm multiplying by 1/8, let's go ahead and divide this by 8 like that. I'm just doing this to show you that if you divide by 8, you have to distribute that to the 8x and the 5. Okay, so let's see here. 8x divided by 8 is x. Well, that's good. We canceled out the 8. But now I've got 5 divided by 8 is 5/8. And moreover, I've got 17 over 8 on this side. So now I've got a bunch of fractions. So it's pretty nasty. Okay, the next thing I'm going to do is, well, looks like x is being added to 5/8. So I'm going to subtract those 5/8 from both sides of the equation. Whenever I do to one side of the equation, I have to do to the other side to keep the equation balanced. So x is equal to 17 over 8 minus 5 over 8. And I hope you can see that 17 over 8 minus 5 over 8 is 12 over 8, which is equal to 3 halves. Now, the more complicated the problem is that you run into, the more ways there are of solving the problem. And sometimes there are quick and easy ways, and sometimes there are harder ways. And I would say that this is the harder way. Okay? So let's not do this. When you see 8x plus 5 equals 17, I want you to think, get this x term alone. Get rid of the 5 first, and then we'll divide by 8 later. Okay? So we'll subtract 5 and divide by 8 afterwards. Makes things a lot easier. Okay, the last type of problem that you're going to run into in 5.1, and you're not even going to run into it tonight on your homework, is when you have x's on both sides of the equation. It really doesn't change much. So let's do it again. 3x minus 5 is equal to 5x plus 1. Really simple fix here. Now you might be thinking, well, what's happening to the x? It's subtracting 5 and multiplying by 3. But you'd be wrong, because before we can do that, we have to get our x's to one side of the equal sign. We want to get them all together on one side of the equal sign, and then we'll isolate of the x. Okay, so you know what I mean. So this is like having 3 bags that you don't know on one side and 5 bags that you don't know on the other side. Well, the first thing we should do is let's just take 3 bags off of both sides. And the way that we do that mathematically is we're just going to subtract 3x from both sides. Okay. Now you might be thinking, why not subtract 5x? And I'll talk about that in a second. Okay, so when I take 3x off both sides, well, these x's are all gone. I'm left with, negative 5 on the left side. 5x minus 3x is 2x, and now I still have a positive 1 on the right side. Okay, now here I can go ahead and isolate the x. So we're going to subtract 1 from both sides. Which gives me negative 5 minus 1 is negative 6. These ones cancel out. I'm left with 2x. And now, of course, 2 times x, well, to cancel that out, I'm going to divide by 2. And negative 6 divided by 2 is negative 3, which is equal to 2's cancel here. X. X is negative 3. Something to point out here. Again, every step gets us closer and closer to getting our x's to one side and finally getting our x completely isolated. Now let's go ahead and check this solution here. So we're going to say 3 times negative 3. That's me just writing this equation and substituting negative 3 minus 5 is equal to 5 times negative 3 plus 1. Let's see, 3 times negative 3 is negative 9. Minus 5 is negative 14. 5 times negative 3 is negative 15. Plus 1, sure enough, is negative 14. It checks out. After a while, if you're doing your steps correctly, you're going to realize that you don't need to do this step. If you follow these steps correctly, you'll never get around those. Okay? Let's do one more example. I'll talk about the thing I want to talk about. Okay, last one. 2x plus 7 equals 6x minus 9. You know what? Let's actually make this negative 6x. That's good. Alright, so what we're going to do here is you might be thinking, well, what side do I get my x's to? And I'm going to tell you the easiest way to do this, and I'll do it both ways just to show you, the easiest way is to take your x's and move them to the side that has more x's. Okay? Now 2 is greater than negative 6. So what I'm going to do is I'm going to get rid of these x's on the right. I'm going to move all the x's to the left. And the way I'm going to do that is by adding 6x. Okay? This is negative 6x. If I add 6x, these 2 x cancel. So I'm going to add 6x to both sides of the equation. That'll give me 8x plus 7 is equal to, this is gone, negative 9. Okay, and now I have just a basic equation. I have multiplying by 8 and adding 7. Get rid of the 7 first. Okay, this gives me, these cancel. 8x is equal to negative 16, and then we'll divide by 8. And that gives me x is equal to negative 2. Okay. Yeah, basic stuff here. Basic stuff. Let's go ahead and on the right side of the screen, we'll do it the other way. So 2x plus 7 is equal to negative 6 minus 6x minus 9. Now let's say I go the other route. Okay. I'm going to subtract 2x. Here I added 6x to get rid of this. This time I'm going to cancel out the 2x. And it still works. I just want you to know. It's a different way of doing the problem. And it still works. But there's maybe a little trick to it. Or maybe something that could cause problems later. So we're going to subtract 2x from both sides. This cancels. I'm left with 7 is equal to negative 6x minus 2x is negative 8x minus 9. Okay, now over here, I need to add 9 to both sides to isolate my x term. Plus 9 to both sides. That gives me 16 is equal to negative 8x. And this is why I think you should do it this way, because now you have to divide by a negative number. That's not really a big deal. I really hope that you can divide only by negative numbers by now. But it's just one more thing that could trip you up. Okay, so that's what I recommend. But if it's too much to think about, whatever. Just do it. So here we're going to divide by, what do we multiply against by? Negative 8. So we have to divide by negative 8. If I just divided by 8, I would still have a negative sign here. So we want the negatives to cancel, and we want the 8s to cancel. So we'll divide here by negative 8. 16 divided by negative 8 is negative 2. And as you can see, we get the exact same answer. Just the negative sign might trip you up. Okay? Alright, so good luck on this, and if you have any questions, I'll see you tomorrow.